This lesson is about constant sums and constant differences, and how to graph them. First, remember what the word constant means. It means unchanging. A constant sum, like x plus y equals 5, is called a constant sum because the sum is constant. X and y can change, but the sum does not. When we graph these equations, or any equations, we start by making a table. If it's a word problem, we start by letting x represent one thing, one of the variables in the problem, and y represents the other. Then we fill in the table. To create the graph, we start by labeling the x and y axes, and that includes putting number scales on the axes. Always label the axes. Then we're going to graph ordered pairs from the table. They're called ordered pairs because, well, they're pairs. There's two numbers, an x and a y, and they're in order. The x goes first. After we plot those points on the graph, we connect the points only when we can have fractions or parts based on the situation. For example, if x represents the number of people, the domain is whole numbers, so we would use dots on those whole numbers. If x represents time, then we can use parts of hours. The domain is positive real numbers, so we would connect the dots. Here's an example. You need to buy breakfast for a dozen people. Each person will get one item, and you decide to purchase donuts and bagels for the group. There are different ways you can buy the dozen donuts and bagels, and we're going to graph the possibilities. So, to make the table, we start by letting x and y represent something. We could say, for example, x equals the number of bagels. Y equals the number of donuts. And it's important to be clear here what we're talking about. There are a lot of numbers that could be associated with bagels. The cost, the weight. We're talking about the number of bagels, and so we want to make sure that we're clear when we define our variable. Our equation, well, what's got to be true? We have a total of 12. So the number of bagels plus the number of donuts, x plus y, equals 12. Now we make a table. X and y go in the table. X could be 6, which means I would have 6 bagels. Then I have to have 6 donuts to get the total of 12. If x is 4, y is 8, x is 0, y is 12. We just fill in the table with some pairs of numbers that make the equation true. Then we plot the points. Well, first we label our axes. Put the number scales on. And there's the point 6, 6. X is 6, y is 6. 4, 8. 0, 12, and 12, 0. And then we can kind of see the pattern. We can just fill the rest of it in. But notice we just put dots on the whole numbers. We did not shade in between. We also don't extend to negative numbers because we aren't going to buy a negative number of bagels or a negative number of donuts. So we do not put arrows on the end. These dots are actually all the solutions. Another example. This one doesn't really have a context. It's just a description of a relationship between two numbers. The difference of two numbers is 8. Difference means subtract, so our equation would be x minus y, x and y would be the two numbers, equals 8. Then we're supposed to graph the ordered pairs. Again, to graph, we start with a table. We need to come up with some pairs of numbers where the difference is 8. 10 minus 2 is 8, so that works. 9 minus 1, 8 minus 0. 7 minus negative 1 and 6 minus negative 2 also work. Don't forget we can use negative numbers. We can also use decimals, fractions. 9.5 minus 1.5 equals 8. And 0 minus negative 8. So we plot those points after we label our axes. Always take a few seconds to put the number scales on, then we plot the points. 10, 2, 9, 1, 8, 0, 7, negative 1, 6, negative 2. Again, we see the pattern. They're going in a straight line. 9.5, 1.5 is also on the line, and negative 8, 0. Now, because this does not come from a problem situation where we have to stick with whole numbers or with positive numbers, we will connect the dots. Make a straight line, put arrows on the ends, and then label the line with the equation, x minus y equals 8. Thank you.